Okay, so at least just give me the x value of where you think the horizontal tangent line is. Very good. Okay, how do we prove a horizontal tangent line?
Do the derivative.
The derivative has to equal what? 0. So that's how you're going to prove this algebraically. We're saying that it's right here. We need to prove that algebraically. So the first thing I'm going to have to do if I'm going to take the derivative of this is put it in polynomial form. So I'm going to write it as g of x equals 2x to the 1/2 minus x minus 2. Is everybody okay? Remember, a root or a radical can be rewritten as a rational exponent, and whatever's in this crack goes on bottom. If it's a square root, you can understand there's just a crack. Okay, now we find the derivative. So that would be 1/2 times 2. One half minus 1, because you remember you subtract. 2's cancel, so you end up with x to the negative 1/2 minus 1. Now that has to equal 0 in order for us to prove that this is in fact a horizontal tangent.
So set it equal.
So set it equal to 0. And now I'm just going to work this out. I'm going to move this over here. That's going to be 1 over x to the 1/2. Right? Because it's unhappy up there is a negative 1/2, so I'm moving downstairs. Now he's happy. So that's the same thing as 1 over the square root of x. So far, so good? Okay. So now I'm going to move the 1 to the other side. I'm pretty confident that y'all could probably do all of this in much less steps, but I just don't want to lose anybody. So I got 1 over square root of x equals positive 1. Clear the fraction, or cross multiply, whatever you want to call it. It's the same thing. So if I put this over 1 and cross multiply, I get 1 equals the square root of x. Gotta get rid of that radical, so square both sides. And x equals 1. We just proved it. Yay! Are we okay?
Almost like I only had to look at
Okay, so it also says I have to give a reason. So g prime of x equals 0 at x equals 1. That's my reason. The derivative equals, and Dylan said it. Derivative has we have to prove it with the derivative. The derivative has to equal 0. You just got to write it down. So the derivative has to equal 0, and it does at x equals 1.
Yeah.
Okay. Number 6, same graph. Now remember, this is where this stuff gets tricky. It's whether or not the graph you're looking at is the derivative, or whether or not the graph you're looking at is the original function. This is the original function. So on 6, they ask the question, on what interval is the derivative less than 0 or negative? Okay, so a derivative, what's a derivative? Slope of the tangent line. Slope of a line tangent to the original function. I need the slope of the tangent lines to be negative, because that's what this means. So all my tangent lines will have to go this way. They'll have to be falling.
Isn't it like 2
Okay.
infinity?
So if that's true, where is that happening on my function? From 1 to infinity. Why? What's happening on the graph from 1 to infinity? It's decreasing. Okay, so g prime of x is less than 0 when g of x is decreasing.
Oh my god, I just love this.
Wait, what?
G prime of x is less than 0. It's negative when g of x is decreasing. When the original function is decreasing.
At least I'm increasing. I was confused.
She said it yesterday.
Now remember, never brackets when you're talking intervals of increase and always parentheses. Okay, where is the derivative positive? When it's increasing. So the derivative is positive when g of x is increasing, which is 0 to 1. On number 8, for what value of x is the slope of the tangent line equal to 2? Slope of the tangent line is derivative. So when they ask slope of the tangent line, they want me to find where g prime of x equals 2. Well, we already found g prime of x up here. So my g prime of x is x to the negative 1/2 minus 1. The fixed version looks like this, 1 over square root of x minus 1. And I need it to equal 2.
Yes.
No.
That's just algebra.
Yes.
So plus 1. 1 over square root of x needs to equal 3. I'm going to put my 3 over 1 and cross multiply. So I get 1 equals 3 square root x. Divide both sides by 3. Now I've got square root x. So I have 1/3 equals the square root of x, but I need just x. Square both sides to cancel the square root. 1/9.
Yeah.
Alright.
Understand the question.
Now we're going to find an equation of the tangent line drawn to the graph of g of x when x equals 4. Then draw the tangent line. Okay, so you need two things to write the equation of a line. You need the slope and a POT. We have our derivative, which is how we find slope. So again, g prime of x is x to the negative 1/2 minus 1. The fixed version looks like this. 1 over square root of x minus 1.
Do we have to write both of those?
And I'm plugging in 4. So So your slope comes out to be negative 1/2. Your POT, we have the graph, so we can just go up and find our POT.
4/2.
4/2. So y minus 2 equals negative 1/2 x minus 4.
What? Oh, okay. Minus, yeah.
And then they said to draw it, so
What'd you say?
It's like trying to pull out the rules.
No, what was
So you're not. The fact that I could even find one was a miracle. Okay. Hey, do y'all have page 155?
No, we have 156.
Oh, it's back.
Yeah, I was just gonna say.
Oh, it's backwards.
What?
Ooh, 155. Found. Go to 155, then we'll come back to
We
156.
don't, I don't
I don't know how that happened.
Oh, okay.
Oh, goodness.
Because he was
It's bothered
he
me.
didn't have that power.
It doesn't bother me, but
Anyways.
I figured it bothers some of y'all.
Sorry. Okay. The table of values below represents all the graphs, represents values on the graph of the derivative. So the table that we've been given is the derivative, not the original function. It's the derivative of h of x, which is a polynomial function. The zero is indicated in the table are the only zeros on the graph of h prime of x. So they're the zeros of the derivative. Use the table to answer questions 10 through 15. Okay, on what interval is the function increasing and decreasing? Give reasons for your answers. Now, before I do anything, I am going to identify where my zeros are. Why are my zeros important? They are max and mins on the original function. So that's going to help me figure everything out. There's two of them. Okay, I'm also going to identify that this goes from right here. This is positive, and this is negative. What does that mean that this is? This is a max. This goes negative, and this is negative.
It just touches and turns.
So it touches and turns, which means this is not a max or a min. So that's going to help when I get to this intervals of increase and decrease. Okay, so where am I increasing on this function? First I'm going to give my reason. H of x is increasing when what is true about the derivative? When the derivative is positive. So h of x will be increasing when h prime of x is greater than 0. Where does that happen? Now, real quick, I don't think they said. It does say it's a polynomial function. This is just a portion of the graph, but they did tell us that these are the only zeros, which means that it doesn't ever change behavior again. So just because they only gave you a portion of the graph, because they told you it's a polynomial function, you should assume that it goes on forever, in whichever places. So in this case, since we know this isn't going to change behavior again, this is going to negative infinity. So from negative infinity to negative 2,
What? Yeah.
it's increasing. H of x is decreasing when the derivative is negative, and that happens. Now this you have to write as two separate pieces, because when it does that touching, it's not decreasing anymore, it's hovering there for just a moment. So this is on the interval -2 to 7, and then 7 to infinity, because of this 0 in the middle. I already figured out where the max is. You have to justify your answer. So I'm just going to say h of x has a max where h prime of x is 0. And the values go from positive to negative. At what value does the graph of h of x have a minimum? Don't have one this
So they don't
time.
have to do.
Does not exist.
Because it doesn't ever go negative to positive, so. Right, if h of 3 is 2, what is the equation of the tangent line to the graph at h of x at x equals 3? What is the equation of the normal lines? Let's do tangent line first. If you're going to write the equation of the line, you need two things. Slope and a POT. What is this? That's your POT. Because there's no prime. So that's your POT. Where are you going to get your slope?
Go to the H of x column where, but
We're going up here to my chart. This is the derivative, which means these are the slopes. Go to 3, my slope should be -3. That is easy. y minus 2 equals negative 3, x minus 3. I like that. All right, normal line. In order to write the equation of normal line, still need a POT. It's the same POT. And my slope, what do I have to do to my slope? Flip it and switch it. So it's going to be y minus 2 equals 1/3 x. How should I identify a tangent? A normal line is perpendicular to the tangent line. Perpendicular lines have negative reciprocal slopes. You start learning that in 10th. Actually, I think we talked about it in 9th. You don't call it a normal line, you just call it perpendicular. But okay. Find the tangent line approximation of h of 3.1. So this is what we were doing on the front page. I can use my tangent line, this value, to approximate 3.1. That's all they want you to do. Just plug in. I put wavy lines because it does say approximate, so that means that this is approximation. Is everybody okay? I'm plugging in and approximating. It's pretty simple. All right, so find the value of each of the following limits. We're using our table up at the top. I want to know with h of x. Now remember, the table that you've been given at the top of the page is the derivative of h of x. But they're asking the original function, as the original function approaches negative infinity, where does my graph approach? What do we determine based upon looking at this? What's happening to this graph?
It's going up.
So, well, we're reading left. So we're reading this way. So if I'm looking at my graph, it's increasing this direction, right? So what does that mean that behavior of the graph is? Okay, this is the derivative, and the slopes are positive. And we determined they're going to be positive all the way back, because it's not changing behavior. If the slopes are positive, what does that mean the original graph is doing?
Down.
It's increasing, right? When you read from left to right. So that means we have no idea what this graph looks like, but we know that this end goes like this. Yes, because it's increasing. Because this is positive. So this is increasing. Which means if we're looking at the original graph and we're going to negative infinity, where is this going? Down to negative infinity. Now we're going to do the same thing on the other end. So this is negative, and we're assuming because this is polynomial behavior that the behavior is not going to change. So that means my slopes are negative, which means that whatever happens in between, this is going this way. So where as my x values approach infinity, where do my y values approach? All right, now flip back.
Oh, boo.
Okay.
There's so much stuff.
Now they've given me the derivative. This is the derivative. It's not the original function. So we don't have to put it in polynomial form because we're not finding a derivative, at least not right now. So they gave me the derivative, and now they're going to ask me questions about the original function. So on what intervals is f of x increasing, decreasing? Justify your answer. Well, in order to know where it's increasing or decreasing, what information do I need about my derivative?
Do the number line thing.
We do. We need to find our zeros, and then then do the number line thing to find out where it's positive
So
and
each
negative.
piece equals
They were nice enough to you to factor it already, so your zeros are easy to see. So my zeros here from looking at this are x equals 0, x equals 2, and x equals negative 3. Because it was already factored, so I just looked at these.
So negative 3 would make that 0, 2 would make that 0, and 0 makes that 0.
Is everybody okay? Now I'm going to set up my number line. Checking numbers. And remember, all you're really concerned about is whether or not it's positive or negative. So this is super easy if you'll just check pieces at a time. So I want everybody, because they factored this, is so easy. If I'm plugging, let's say we're going to plug in negative 4. If I'm plugging in negative 4 right here, my first piece comes out negative. If I plug negative 4 right here, my middle piece comes out positive. And if I plug negative 4 right here, my last piece comes out negative. So the whole thing is negative. Oh, sorry, it's positive. A negative, positive, negative, it's positive. Okay. So now we're going to go between 3 and 0, negative 3 and 0. So let's just use negative 1. If I plug negative 1 right here, my first piece is negative. If I plug negative 1 right here, my second piece is positive. And if I plug negative 1 right here, my last piece is positive, making this interval negative. Going between 0 and 2, let's use 1. My first piece will be positive. My second piece will be positive. And my third piece will be positive. This is positive. Last, I'll use 3. First piece will be positive. My middle piece will be negative. And my last piece will be positive. So this last piece is negative. So f of x is increasing where the derivative is positive and decreasing where the derivative is negative. So increasing on the interval of negative infinity to negative 3 and 0 to 2. And decreasing from negative 3 to 0 and 2 to infinity. So now we've done all the work to answer the rest of the questions. Where's my relative minimum? I have the relative min at x equals 0. Because that's where the derivative goes from negative to positive. I have 2 relative maximums. Okay, on number 19. What do I need? What do I need to do?
You make your slope
I need my slope. They gave me,
your point of tangency.
they gave you a point of tangency, so I have my P of T. I need my slope. into F prime, which is what they gave you at the top of the page, I'm plugging in 4. Negative 56. Now we're going to approximate 4.1. So we're going to use our tangent line to approximate.